All right, so picking back up with understanding this code of just like creating a simple using listen and serve, which takes a port and a handler. All right, so for something to be a handler, it needs this serve HTTP method with these parameters, and so we created a custom type which has an underlying type event, and we attached this method to it. So this now became a handler. So when I create a variable of that type, right, I can now use that as my handler. So when anything comes in at 9,000, we're doing no routing here. It's just any request at 9,000, I'm serving back this serve HTTP, right? So that's the handler method, is like I'm going to serve HTTP. Patrick's like, whoa. All right, so that's you can kind of see how that works. And I could change this, couldn't I? I could change the implementation of this method, and I could have other lines. I could tell it to print other stuff. And right here we actually see an example of write string takes a writer, and this implements the writer interface, right? And so we're able to pass into write string a writer. We could also use that fprint here, and that's what we were just looking at in this code sample right here, right? We could also use fprint or write string because it takes a writer. So here we are doing this one as a writer, and here we are passing into IO write string. That one, that also implements the writer interface. So if we went digging into here, we'd see somewhere in there that's implementing the writer interface. It has that write method. So when we run that, we get hello world. Am I not in full screen? How do I go full screen? Here we go, view, present, make it more. So when you run that, you get hello world. This is Go's version of interfaces. Bonnie, looking in. And so if I do like a sudo curl I to get the information on that, and then ask for localhost 9000, I could see the request header. So this is, which one is this? Is this the request line or the status line? Status line, right? Because we have the HTTP protocol version, and then we have the status number code, and then we have the status phrase, right? Okay. And then we have our headers. After each header, you have what? Carriage return line feed, right? So there we have our headers, and I'm not totally sure why I put this in here, like I guess just to show the header on it. But to show that the header is being written for you, right? Like in that previous example, we were writing the header ourselves. Like, oh, what a pain, right? And here, with HTTP listen and serve, using the stuff that's in the standard library, all that got written for us. We didn't have to do that. So this is all the code we needed. So I typed this out because I just wanted to make sure that it was clearly conveyed. But the variable h is of the type myHandler. And so this pretty much explains what I just went through. So variable h is of the type myHandler. MyHandler is a user-defined type. So it's user-defined type. The underlying type of myHandler is an int. So these are these words we use to... Oh, what's up, Bonnie?
It's about scheduling them.
Oh.
Didn't want to interrupt you, though.
Oh, cool.
It's like you're lecturing, so...
Yeah. Go for it. So this right here pretty much just explains everything that I was just talking about, right? Just kind of lays it out, how that all works. So listen and serve, you put in the port, and then it takes a handler. And if you put in nil instead of the handler right here, it'll use default serve mux. And so mux is a serve mux is a handler. So you'll sometimes see nil put into that. So right here, and default serve mux. You want to take that ticket down, Rio?
Do you have it?
I have to go to my truck, get my key, come back and open the door, but you can let somebody in maybe.
No, he's waiting on me to get down there.
Okay, who's
Sorry,
he?
man. Huh?
All right, cool.
Sorry. Thank you, though.
Yeah. So it just kind of takes a second to wrap your head around how all this stuff works and get familiar and comfortable with it. But one of the main things is the handler interface. Okay, and we saw that for it to be a handler, it needs to implement that method. Type handler
To make it nil, you just leave it blank, or
You type in NIL.
you do actually type it?
Yeah, so, and listen and serve, so that there's the handler, right? And what listen and serve is, listen and serve, right, takes the port, the address, and then a handler, and this is a handler, right? And then we were just seeing that with listen and serve, you could pass in nil, in which case default servmux is used. So that tells me default servmux is a handler. Well, what is default servmux? If we go and we look at what default servmux is, default servmux is just a variable that's set equal to new servmux being run. That's a method. So what is this method, new servmux? It returns a pointer to a servmux. What is a pointer to a servmux? What is a servmux, right? A servmux is this right here. So a servmux must implement the handler interface, which means it's got to have that one method, and that one method would be sorry, I thought it was just going to take me right there. That one method would be handler right there, right? So servmux has to have this method. So that was kind of good. I thought we were kind of following it there pretty well. So let's click through that. So listen and serve, right? Takes the address and a handler, and this is a handler. Okay, and you could also pass in nil for the handler, which means default servmux is also got to be a handler. So default servmux is a variable. And when you put default servmux in, it's just like basically runs this method. So what is that method? Gives me a pointer, to a servmux. What is a servmux? Well, here's a servmux, and that tells me that a servmux needs to have this method to be a handler. So serve HTTP. So here's my servmux, and let's look at it here. Servmux, whoops, servmux. There it is. It's implementing that method, and now makes it a handler. And the way it implements all that code could be, who knows, right? Like area for a circle is different than area for a square, but it just needs to have that, because now when that method is called by whoever's calling it, right? It implements it. If it's a circle, it implements it the circle way. If it's a square, it implements it area the square way. Going back to when we talked about interfaces, right? To use that analogy. And so that's really kind of like that little process right there of just like how are things connecting is how I look at the docs. And so just recently I did this code, and this is a really nice chunk of code. I'm really happy with it. Remember we did the photo blog, Bob? And so I put together this one right here, Gorilla Photo Blog. So let's just take a look at that. And I'm pretty sure that's not an app YAML, so let's just go run main. And which port is it on? 8080. This is actually just one photo. Right? And so it's just a photo blog. But right here I was stuck in the photo blog because I wanted to hash the photo and do like a SHA-1 on it. And so I get the SHA-1, and then I'm going to use that as the file name just to make unique file names. But once I had sort of done IO copy to do the SHA-1, then well, this isn't So I was able to use IO copy to do the SHA-1, and because if we look at IO copy, let's see here, copy takes a writer and a reader, right? And so anything that has a writer and reader, I could use that. And so here, this implements the writer interface, and this right here, multi-part file, has the reader interface, right? You could read a file. And so if I went and I looked at multi-part file, right, somewhere, oh, here it's an interface, it's just a collection of interfaces, so it just tells me, like somewhere in here, you know, the files implementing all the things necessary to implement those. But anyhow, then I was able to look at IO copy and use it in that situation because I knew I had, oh, this has the reader interface, this has the writer interface. I want to write from this, read from this, and write to that. You know, so I was able to implement it. All right, so let's see what else we see here. So what's different here? You know, we create a user-defined type. We attach this, which makes this type a handler. And then we create a variable of that custom type, user-defined type, and listen and serve, same thing. And any path, you know, it's just showing any path, right? It's just always using the same handler. And what I'm having it do here is I'm getting the request URI. So that's all this stuff right here, and I'm just printing out the request URI. And so you could go to NetHTTP and you can look under the request. So let me just look at NetHTTP. And if I go and I look under request, right, I have all these methods. So here's my type request and different methods I could use. But here under type request, it's a struct. And some of the stuff it has is like URL. For client requests, the URL's host specifies the server to connect to, while the request host field optionally specifies the host header. That really doesn't tell me what. It specifies either URI being requested or the URL. And then I also have down here request URI. Here we go. Unmodified request URI of the request line as sent by the client to the server. Usually URL field should be used instead. It is an error to set this field in an HTTP client request. So if I look at the URL deal, how would I use that? Well, I could come here, and when URL is used, it gives me a pointer to URL. So let's go look at that from package URL, type URL. So I could go look, and you can see I'm now a net URL, so different package inside the net package. And URL has path, right? So maybe if I use URL path, it'd then show that to me. So in this code right here, right, I used request URI, but let me just see if I have it any other way. Here I have request URL path, right? So request URI and request URL path, those are two ways I could have gotten the same thing. So we jumped in a little bit into the deep end with this stuff. Not everybody else is here, but you know that's the beginning. So we go back to our code sample. Code samples. We were looking at, I think this first one. Right, listen and serve, the address, and then a handler. HTTP new serve mux. We saw HTTP new serve mux, right? So HTTP servmux, new servmux. HTTP new servmux gives me a pointer to servmux, which then means it's implementing the handler interface, since it has that. So I can now use that mux as the handler. And then the mux allows me to do things like handle func, because I have this method here, handle func. And when I use handle func, right, has to have that sort of a setup. So handle func needs a route and then the function. So here's the pattern string, the route. And then I need a handler func. And a handler func needs to be a function with this response writer request. So response function with this response writer request. Handle func, right, needs that. Handler func. So I'm able to do that. You guys have any questions? No? It's good. By the way, really impressed Bob, like when I wanted to like almost show that in class, but like your photo blog that you showed, it's very cool. Nice formatting. So do you guys want to code some of this?
I'm going to
Yeah?
lecture tonight, and I want to get something to eat.
Okay, cool. So why don't we try just coding up this one here, and then we'll call it a night.